Today we will discuss matrices and determinants. A matrix is a rectangular array of numbers enclosed in brackets. The numbers are called elements of the matrix. For example, 2 by 3 matrix. You can see that the first row 1, 4, 6, row 1, that is a horizontal. 2, 5, 7, the second row. Also you can see that the vertical 1, 2, the column number 1 elements, 4, 5, column number 2, 6, 7, column number 3. So the general form of a matrix is A11, A12, A13, A14, etc. A14 means first row, fourth column elements. Similarly, you can see that A23, that is second row, third column elements. So A32, third row, second column elements. In the same way, you can write any number of items. So again, an example is 3 by 4 matrix. 2, 4, 5, 6, row number 1, 6, 3, 2, 4, row number 2, 1, 3, 4, 5 are row number 3. Again 2, 6, 1, column number 1, etc. and goes on. For a general case, we can say that suppose that 3 persons, Jones, Joby and Boss, go to a supermarket and purchase the following items. Jones, 2 apples, 6 lemons and 5 mangoes. Joby, 2 dozen eggs, 2 lemons. Boss, 10 apples, 1 dozen eggs and 2 dozen oranges. So we can use this example. We can construct a 3-5 matrix whose rows give the various purchases of Jones, Joby and Boss, and the items apples, lemons, mangoes, eggs and oranges. So in the sudden question, how many oranges Boss bought? The answer is 24. So intersection of oranges and Boss column, you can see that answer is 24. That is the use of matrices in general case. So a simple question we can ask: in a matrix there are 12 numbers. How many ways we can arrange? So there are 12 numbers. We can arrange 1 by 12. That is 1 row, 12 columns. And again 12 by 1, 12 rows and 1 column. And 3 by 4, 3 rows and 4 columns. 4 by 3, 4 rows and 3 columns. 2 by 6, 2 rows and 6 columns. And 6 by 2, 6 rows and 2 by columns. The easy way to think that is, how many factors 12 has? That is 1, 2, 3, 4, 5, 6. There are 6 combinations. Another example, in a matrix there are 13 elements. How many ways we can arrange? Because you know 13 has 2 factors, 1 and 13. One we can write 1 by 13 and other we can write 13 by 1. In 1 by 13 you know is only 1 row, 13 columns. We call it as a row matrix. And again 13 by 1, 13 rows and 1 column. We call it as a column matrix. So different types of matrices. Simple first is rectangular matrix. That is rectangular matrix having number of rows is not equal to number of columns. Examples 1, 4, 6, 3 by 7. That is it has 2 rows and 3 columns. So it is an example of a rectangular matrix. Again square matrix. A matrix having number of rows is equal to number of columns is called a square matrix. Example 10, 11, 12, 5, 6, 7, 12, 11, 4. It has 3 rows and 3 columns. So it is an example of a square matrix. Another is zero matrix. In a zero matrix, you know all elements are zeros and it is denoted by capital 0. So the example 0, 0, 0, 0, that is an example of a 2 by 2 zero matrix. The number of other matrices are available: upper triangle matrix, lower triangle matrix, etc. The important, we will discuss only the important diagonal matrix. So in a diagonal matrix, you know that for example we can see that 2, 0, 0, 0, 2, 0, 0, 0, 6. So you can see that there is 2, 2, 2. These known as main diagonal elements. So you can see that above the main diagonal elements and below the main diagonal zeros are coming here. So such a type of matrix are known as diagonal matrix. And again we will discuss scalar matrix. A scalar matrix is a diagonal matrix in which the diagonal elements are equal. So you can see an example of 2, 0, 0, 0, 2, 0, 0, 0, 2. So all diagonal elements are equal, 2, 2, 2. Again we can say that 5, 0, 0, 0, 5, 0, 0, 0. These are examples of scalar matrix. Next is identity matrix. An identity matrix is a diagonal matrix in which diagonal elements are equal to 1. So you can see that example 1, 0, 0, 0, 0, 0 1 0 0 0 1. So it is a 3 by 3 identity matrix. It is usually denoted by I or I3, or in 4 by 4 we can write 1 0 0 0 0 1 0 0 0 0 1 0 again 0 0 0 1. So in any way we can I5 I6 I7 etc. you can write. Okay, then another type of matrix is transpose of a matrix. What is, we are transposing, that is interchanging rows and columns of a matrix. For example, a matrix A is equal to 2 3 0, second row 1 2 0 3 5 6. So you can see that A transpose, it is denoted by A raised to T or A raised to 1. So you can see that the first column becomes first row, second column becomes second row, and third column is the third row. So there are number of properties of transposes. The first property is A transpose the whole transpose. We are taking transpose, again taking the transpose, again the same matrix will come, that is A transpose the whole transpose is equal to A. And second, we are adding two matrices and taking the transpose, which should be equal to, we are simply taking individual transposes and adding. So A plus B the whole transpose is equal to A transpose plus B transpose. Again, a scalar multiple into transpose is equal to a scalar multiple into A transpose. The next is very important. AB the whole transpose is equal to B transpose into A transpose. We are multiplying two matrices and taking the transpose is equal to, we simply multiply the second matrix, take the transpose, and again with the first matrix and take the transpose. Okay, AB the whole transpose is equal to B transpose into A transpose. Number of other matrices are there, singular matrix and non-singular matrix, that we will discuss later. Now, very important thing we are going to discuss is symmetric matrix. So, a symmetric matrix is a matrix. Its matrix is equal to its transpose. Simply, we can say A is equal to A transpose. And this anti-symmetric or skew-symmetric matrix, that is A transpose is equal to minus A or A is equal to minus A transpose. Then we will discuss orthogonal matrix. A matrix is orthogonal. If A into A transpose is equal to I. You know, already we discussed I is equal to unit matrix. Then now we are going to discuss matrix algebra. So as like real numbers, matrix as addition, subtraction, equality, etc. First of all, we will discuss matrix equality. You know, two matrices are equal if they have the same size or same dimension, and also their corresponding elements are equal. So for example, if A is equal to xy first row, zw second row, and B is equal to 3 5 and 6 7, A is equal to B means the first x is equal to 3 and second element is equal to 5 and z is equal to 6 and w is equal to 7. Matrix addition and subtraction. So if we want to add two matrices or subtract two matrices, they are of the same order. So for example, you can see that A is equal to 1 2 3 5 6 7 and B is equal to 10 1 23 and 5 16 3. So A plus B is equal to simply adding the corresponding numbers 1 plus 10, 2 plus 1 and 3 plus 3, etc. etc. And A minus C also same trick you can apply. Then multiplication of a matrix by a scalar. You means a scalar is a constant. If you want to multiply a matrix by a scalar, you have to multiply each element by the each element of the matrix by the scalar. For example, if A is equal to 3 4 5 6 7 8 and 5A, 5 is a scalar, we can see that 5 into 3 you can 15, 5 into 4 20, 5 into 5 25, 5 into 6 30 and 5 into 7 35 and 5 into 8 40. So another example we can see that first row consists of 2 3 4 5, second row 3 4 5 6 4 5 6 7. The four columns represent the four shops A1, A2, A3 and A4 respectively. And B represents the number of items of different types delivered at the beginning of a week, and matrix C represents the sales during that week. Then somebody is asking about the number of items immediately after delivery of items. So just simply you have to add A and B. And now again the another question is the number of items at end of the week. Very simple, you are adding A plus B minus C. This is a simple application of matrices. Then as I mentioned, you can see that another question, A is equal to 1 3 9 1 and B is equal to 5 4 1 5. Find the matrix X such that 5A plus 3B plus 2X is equal to 0. So it means 0 is a bold 0. That means we are adding all the matrices. The answer is always a matrix. And another thing, you can see that A is a 2 by 2 matrix, B is a 2 by 2 matrix, and X is all or should be a 2 by 2 matrix, and a 0 matrix also should be a 2 by 2 matrix. So in this case, X is not given. In that case, we take X is equal to X, Y, Z, W. X, Y, Z, and W are unknown quantities. For example, 5a plus 3b plus 2x is equal to, first of all, you have to find out 5a, that is, you have to multiply each and every by with the 5, and 3b, each and every element with the 3, and 2x, and each and every element x, y, z with the 2, and equated to 2 by 2 matrix, because answer is always should be as 2 by 2 matrix. Then multiplying and adding, we get a 2 by 2 matrix. The right answer is a 2 by 2 matrix. Then we apply the trick of equality of matrix. Then first element is equal to 0, and 2 plus 20 plus 2x is equal to 0, and 2x is equal to minus 20. The answer is x is equal to minus 10. Similarly, we equating other three quantities. We can answer is equal to y is equal to minus 27 by 2, and z is equal to minus 24, and w is equal to minus 10. Then find x and y. Another example, 1 x plus y, x minus y is equal to 0, 1 3 1 0. Here also the first part is 2 by 2 matrix, the right answer also 2 by 2 matrix. So we can easily equal the matrix. The first element is equal to, that is, x plus y is equal to 3, and x minus y is equal to 1. Then adding and solving these two equations, we get x is equal to 2 and y is equal to 1. Then multiplication of matrix is very important. So if you want to multiply two matrices, the column number of the first matrix should be equal to the row number of the second matrix. Otherwise, we can't multiply these two matrices. So, for example, A is equal to 1, 2, 3, 6, 5, 8. Its order is 2 by 3. And B is equal to 5, 6, 7, and 4, 7, 8. Its order is 2 by 3. You can see that the column number of the first matrix is 3, but row number of the second matrix is 2. So, we can't multiply these two matrices. Another example, A is equal to 2, 3, 4, 1, 5, 6. And B is equal to 4, 6, 7, 3, 2, 1, 1, 3, 4. So you can see that the A is 2 by 3 and B is 3 by 3. You can see that the column number of the first matrix is equal to the row number of the second matrix. So we can multiply these two matrices. Then order of the multiplied matrix AB is 2 by 3. We take the row number of the first matrix and column number of the last matrix. Then how to multiply? You can see that first row into first column, we get first row first column element. So first row 2 into 4 plus 3 into 3 plus 4 into 1. So first row first column element, we get first row first column element after the multiplication. Then first row into second, 2 into 6 plus 3 into 2 plus 4 into 3. That is the second. Third, 2 into 7 plus 3 into 1 plus 4 into 4. Third element. That first row is over. Then we take the second row, 1 into 4 plus 5 into 3 and 6 into 1. Similarly, you can find out AB. So you take the answer as AB is equal to 21, 30, 33, 25, 34 and 36. Another example, A is equal to 1, 2, 3 and B is equal to 5, 7, 8. We can check whether it is possible to multiply these two matrices. So we take the dimension or order of A is 1 row and 3 column, that is 1 by 3, and the order of B is 5, 7, 8. So it has 3 rows 5, 7, 8 and only 1 column 3 by 1. You can see that the column number of the first matrix 3 is equal to the row number of the second matrix 3. So we can multiply these two matrices. Then order of the multiplied matrix is 1 by 1. We take the row number of the first matrix and column number of the last matrix, that is 1 by 1. That is a single number. So you can see that answer is correct. So 1 into 5 plus 2 into 7 plus 3 by 8. Adding all, we get a single number 43. That is equal to, it has only 1 row and 1 column. The number of other examples are there in the practical life. We can discuss the another thing, example, how to do a problem. A is equal to 2, 3, 3, 5. A cube plus a squared minus 24a plus 36i is equal to 0. So a cube means we have to multiply a 3 times. A, first of all, you have to find out a into a. We get a squared. Then again multiply with the a. There's a confusion among the students that a cube means we have to cube the elements of the matrix A. It is not correct. A cube means A into A. That is A into A, first of all, A squared. Then you have to multiply with the, we get a cube. Then A squared 24A plus 36I. I, you know, it is a 3 by 3 matrix. I is always 1, 0, 0, 0, 1, 0, 0, 0, 1. Then we are adding all these numbers and subtract with the 24a and adding with the 36. The answer is equal to 0. If it is 0 on the right hand side, we can say that the answer is correct. Now, then we are going to discuss what is the determinant of a square matrix. There's a confusion among the students. What is a determinant? Determinant is that means only square matrix has determinant. Determinant means to every square matrix they are associated a real number. That number is known as the determinant of a matrix. So it is denoted by DTA, or we are writing in two parallel lines. In between parallel lines you have to put a. How to read this is determinant of A. So for example, 3 1 matrix A is equal to 3 1 5 2 is determinant is 3 1 5 2, or we call it as determinant of the matrix 3 1 and 5 2. Then how to find out the determinant of a 2 by 2 matrix? So you can see that A B C D, the matrix A is equal to determinant of matrix A B C D. How to evaluate? So you have to multiply A into D, the off diagonal elements minus main diagonal elements AD, A into D minus off diagonal elements CB. So answer is AD minus BC. It's very easy. AD, you have to multiply main diagonal elements A into D, that is AD, minus off diagonal elements C into B. That's a trick of evaluating a 2 by 2 matrix. Then what is how to evaluate a 3 by 3 matrix? So you can see that how to evaluate a 3 by 3 matrix. So for example 1 3 2 4 1 3 2 5 2, determinant 1 3 2 4 1 3 2 5 2. Its matrix is A is equal to matrix 1 3 2 4 1 3 2 5 2. We are going to find out the real number. Which is the real number associated that matrix? That is, you have to find out the determinant of a matrix. So you have to write in parallel columns 1 3 2 4 1 3 2 5 2. How to evaluate? We can evaluate determinant either by rows or either by any rows or any columns. You can evaluate 1 3 2 or 4 1 3 or 2 5 2 or 1 4 2 3 1 5 4 2 3 2. For easiness, we always take along the first row. So we take the first element 1, then we strike out the element containing one row and column. That is 1 4, we are deleting 1 4 2 and 1 3 t. Determinant is the remaining subdeterminant is 1 3 5 2. We always take the second element as minus, that is here is positive, we take it as minus 3, and we strike out this column and this row. The remaining subdeterminant is 4 3 and 2 2. Then third element is plus 2, and so we strike out the element containing 2 and row, the remaining is 4 1 2 5. Then you know already we discussed how to evaluate a 2 by 2 matrix. You have to multiply 1 into 2 minus 5 into 3. So minus 3 into 4 into 2 minus 2 into 3 plus 2 into 4 into 5 minus 2 into 1. So evaluating all these, we get the answer is equal to 70. So another example, how to evaluate A is equal to 4 5 6 7. So determinant of A is equal to 4 into 7 minus 6 into 5. So this session will be continued in the next video. Thank you.